Hello, Cal 3 students. In this video, we will be talking about rectangular, cylindrical, and spherical coordinates. And it's a little bit more about the derivation. We're kind of currently doing this in our class, and they're useful in evaluating triple integrals. What I want this video to be is kind of to show you where exactly spherical coordinates come from and how they're related with the with cylindrical and also with rectangular. Here we have the formulas that I gave you in class, but here I'm gonna give you guys a little bit more about how we acquire these formulas, because they're not quite, you look at them and they're not obvious. So all it really is just a lot of geometry. So what I'm gonna do is I'm gonna attempt to draw this point. So remember that with spherical coordinates, basically what you're doing is you're defining a point using a distance and two angles. So what I'm gonna do is I'm gonna pick a point, let's say this guy, and this in rectangular coordinates or Cartesian coordinates is p x comma y comma z, which is what we've been working with so far. And basically what we're gonna do is we're going to define this distance from the center all the way to this point as rho. Okay. Remember that what you can do is that we can the projection to this point onto the xy plane is basically going to be the distance z. So this whole distance is just going to be z. I can look at this projection point, and I can now look at it from the origin. So like this. And you can see that in this direction, this is just going to be r. That r is just going to be the radius from polar. Okay, so that's just r. So if that's r, that means that the angle between the x-axis to that ray r is going to be theta. Okay, now using a little bit of geometry, you can kind of draw another parallel ray going this way. Let me extend my z-axis a little bit more. And you can see that this guy is also going to be r. And remember that we have one final variable, which in this case will be phi or phi. So that's going to be the angle between the positive z-axis onto rho. So that's going to be phi. So now that I have all of my components, individual components, what I want to do is define or express this this point with rho, theta, and phi. So once we do that, you'll see that converting it to cylindrical coordinates is a lot easier to work with. All right, so the first thing that I'm going to notice is the following thing. So we know that x is equal to r cosine theta. That's just by polar coordinates. Okay, and what we're going to look at the above triangle. So we're going to look at this guy. So let me shade it. We're going to look at this triangle right here. This above triangle. Okay, you can notice that this is a 90-degree angle. Also, this guy's going to form a 90-degree angle. Okay, that's the bottom one. And if you kind of take a look at that, if I want to express my using right triangle trigonometry, express a trig function with phi, you can see that this is just going to be sine, the sine opposite over the hypotenuse. So you're going to see that sine of phi is going to be r over rho. And if I were to express this a little bit better, you can see that r is equal to rho sine phi. Okay? Because we know that x is equal to r cosine theta, well, now we know what r is in terms of rho and phi. I can plug that guy in there. You can see that x is going to be equal to rho sine phi cosine theta. So this is my first conversion. So I can, if I'm given the 3 points, rho, theta, and phi, I can convert it to rectangular, which is basically this formula up here. Okay. So that's my first one. Okay. Now y is going to be similar. Okay. So with y, we're going to do exactly the same thing. So we know that y is equal to r sine theta. Okay. So we're going to do the same exact thing. So now instead what we're going to do is do the following. Take y. So we're going to take this y. Now we know what r is. R is just this rho sine phi. So then we're going to write that rho sine phi for the r. And then we just have sine theta. So that is my other one. That's just this, the second one. Okay. All right. And now with z. So how are we going to work with z? So one of the things that you can also look at is that because we know that this entire distance is z, by geometry we know that this distance is also z. So I can express the z coordinate using the cosine. So for that one, you'll just see that the cosine of phi is equal to z over rho. And then you can see that z equals rho cosine phi. So that would be that one. So cool. We now have all of these formulas. So we derived all of these formulas using geometry. Now, how do I get these ones? Well, these are actually not that bad. One of the things that you can look at is that in order to derive the first one, the rho squared equals x squared plus y squared plus z squared. One of the things that you can do is that you can look at this entire thing, entire triangle, and just use the Pythagorean theorem. So we can see here that for that guy, you just got that z squared plus r squared. Or let me just write it as r squared. We know that r squared plus z squared equals rho squared. That's using this above triangle. And we know that r from polar is just x squared plus y squared. So then we just have this extra z squared, and we got this rho squared. Okay, so that's how you derive that guy. Okay. Now, how do we know the tangent of theta? Well, that one's kind of obvious because you can just obviously see this theta just using regular right triangle trigonometry. That one's pretty obvious. This one is just really a nothing, right? We've already derived this one from polar. And now how do I get this guy? Well, one of the things that you can do is you can use the fact that I know that z is equal to rho cosine phi. And if I want to know what phi is, well, I can divide by rho to the other side. So I get z over rho equals cosine phi. And now I'm going to take the arc cosine. So I get that phi is equal to arc cosine of z over rho. Okay. So that's kind of how you get that guy. Well, remember also how we can define rho. Remember rho, we got this guy. If I take the square root of this guy, I'm going to get the square root of x squared plus y squared plus z squared. So then phi is just going to be the arc cosine of z over x squared plus y squared plus z squared. And this whole thing is square rooted. So that's how you get that third component. Okay. So a lot of really trigonometric things going on here. All right. So now the last one is basically, so that was the first one, rectangular to spherical and spherical to rectangular. So that's how you kind of acquire these formulas. And now the last ones are actually not that bad. To be able to figure out the cylindrical are actually pretty easy. You're kind of just basically doing the same exact thing. Notice that I've already kind of derived some of them. You can see that r equals rho sine phi. We've already defined it. Whoops, I don't know what I'm doing here. R equals rho sine phi. We've already did that, right? And that's just our first equation, this guy. So this one we already did it based on using this trigonometry. Okay, theta obviously is theta because the theta is the same exact thing as spherical and cylindrical. Z equals rho cosine theta. I'm sorry, rho cosine phi. Well, we got that from over here. Same thing using this triangle. Okay, that's how we got that guy. So these guys were all good. We've already did them when we were trying to like use convert rectangular to spherical. How do we get this guy? Well, that one's pretty easy, right? Because we know that rho squared equals x squared plus y squared plus z squared. We know that this guy is just r squared, and then I just take the square root, so I have the square root of r squared plus z squared. Okay. This guy, theta equals theta, same thing. And this guy, well, it's just also really easy, right? Because we know that this guy is just equal to r squared. So you just do a substitution here. Okay. So that's kind of how you would go about deriving all of these different things. They're really not too difficult if you know a little bit of geometry, but I wanted to give you guys an explanation of how all of these are related to each other.